I'm making a video game with underwater mechanics. In this devlog, reworked scoring system, new enemy, next world tiles, bug fixes. A playtester pointed out a discrepancy in the scoring system, so I started by writing a test case for that scenario. I created a new struct that holds a detailed breakdown of how the score was calculated based on categories. This will help both in debugging and to make the scoring UI flashier. I then started on the new implementation, making sure the first test case passed. I created a testing that would let me download all the previous scores for a level so I could use those to come up with more test scenarios. Since some of the boards have more than 8 entries, I made a new scrollable leaderboard. This same component will be used for the friend score panels. The new scoring implementation has scores that start at 100,000, so I checked that the panel can handle numbers of that magnitude and scale correctly. Using the previous scores, I added more basic test scenarios and updated my implementation. Then, I added tests for scenarios I figured would be problematic. Happy with the new implementation, I worked on a tool to download all the results into JSON files so I could reference them in the future if needed. For comparison, I added a second panel that would load results with the updated scoring system and spot check that the new leaderboards looked right. The new implementation has the simple goal of guaranteeing that faster times score higher when everything else is equal. One of the Coral Castle levels had the most discrepancies in the older system since chests gathered weren't weighted as heavily, so I compared those results. The new implementation also cares about the quality of chests. For the final check, I updated the game manager to use the new scoring system. Leaderboards will be reset at some point anyway, so these scores being much higher is not a big deal. Based on player feedback, I decided to separate scores from progression. The previous implementation required that you gather all chests in a single run in order to progress and unlock new levels. The new implementation counts any chest you gathered, whether it was in the same run or not. This feels better since the leaderboards already reward you for the amount and quality of chests gathered. If a player was stuck on a level previously, they could potentially miss being able to unlock all levels. A user reported that the pause menu switches to keyboard keybinds when they are on a controller occasionally. I did some research and ran into this post which mentioned issues with UI and not setting the event system correctly, but that didn't fix my problem. Adding some console logging showed me that a mouse pointer event was being received when using a controller. As a workaround, I added some code that requires multiple mouse events to be detected when switching from a gamepad to keyboard. Now a user can pause and unpause when using a controller and not have the buttons change on them. As a final test, I ensured the controls changed correctly based on input outside of the pause menu. While playing with keybinds, I noticed that reassigning the move right key did not reset when using the restore all button. Since this is a composite binding, I needed to search through all the bindings for that action to find the right index. This simple change fixed that bug. While fixing this, I noticed that I was consistently searching through all bindings, including the UI ones. So I swapped that loop to only search through the player action map. Part of the feedback I received was a quality of life request for the world map to remember what level you had previously selected. Previously, the selection would reset to the first anchor when opening and closing the leaderboards. With the new state tracking system for the anchor, I checked that the world map would correctly select the level you just exited out of. Then, double-check that the feature also worked when you completed a level. The state is tracked in a singleton and keeps track of the selection anchor and the level setting scriptable object as you navigate to the world map. Since button references would be lost when switching scenes, the world map manager handles the logic of rediscovering the right button when it loads from a different scene. When I first started working on the game, I made a couple patrol behaviors and had a version of a jellyfish working. I started by setting up a small area to test the mechanics of the jellyfish. I set up the old jellyfish prefab and tried it out just to refresh my memory on how it worked. The old implementation never made the player stick to the top of the jellyfish. Additionally, the patrol mono behavior for that prefab used some scaling changes when switching directions. Knowing these drawbacks, I first tackled making the jellyfish become the parent of the player. I wasn't sure if it was as simple as that, so I used this tutorial by Jason Wyman as a starting point. I then created a mono behavior that was responsible for handling the parenting behavior and attached it to the head component. With the current patrol component, a very funny scaling bug would often occur when you hit the edge of a jellyfish. This was caused by setting the parent of the player to the parent of the jellyfish, instead of just the jellyfish, so the patrol scaling change affected the player as well. Changing this fixed that problem. With the mechanics mostly figured out, it was time to make some art. I started the art for the jellyfish by drawing a bunch of head shapes and landing on a shape I liked. My wife suggested I try to animate the jellyfish, so I gave that a shot and was happy with the results. During this phase, I also played with variations of colors in order to land on a set of colors that wouldn't blend in with the background. With the jellyfish being animated, I first focused on updating its collider shape while it animates. I set up the animation controller and swim animation prior to messing with the collider shapes. I soon found that the animator does not work with polygon collider properties. So I tried just working with a box collider 2D and editing the shapes, which did shrink with the animation, but the shape never matched the head quite right. Since the polygon collider is based on shapes, I tried editing the physics shape on each sprite and seeing if that would update as it animates. The physics shape did not automatically update based on sprite. Before spending time solving the polygon collider problem, I tested out the animation with the player on top. The collider switching dimensions didn't seem terrible, so I decided to spend time solving the shape problem. The player character switches collider dimensions while swimming, so I used that as a base for a solution that would swap the polygon collider points programmatically. I made a script that built a set of polygon points based on child sprites and would swap to a given set based on a number. The jellyfish animation simply calls that script to set the next set of points using an animation event. Since this solution worked, I created a scriptable object that could more easily build the data points. After importing all the points, the collider's dimensions changed based on the frame. It did have some odd behavior with the collider changing prior to each event. Since I was using a property for the step, the animation timeline interpolated the value and would round up prior to the next animation event. Instead of using a field, I updated the function to take a value when called by the animation event. This led to a much more consistent collider swapping experience. While testing, I noticed that the jellyfish had some jittery behavior when it swaps directions. I had a suspicion this was due to the patrol script flipping the local scale, so I disabled that portion. That did end up fixing the jittery behavior. As a last step, I added a child component that contains the collider for the tendrils and the damage script. I wanted to double check that the animation events would work fine with prefab copies, so I set up 3 jellyfish copies to test things out. Gladly, it all worked fine. I spent a lot of time making different variations for the ship tiles. The first pass looked more like bricks and wooden planks. I tried a second attempt using less divisions, and this version looked slightly more like wood planks, but I was still not happy with it. I was lucky enough to catch Adam C. Unit streaming and asked if he could show me some of his wooden pixel art. Thankfully, he showed me a few samples I could study. With Adam's references, I worked on another set of versions that had even less breaks between the wooden planks, and I think that's a good first version. I think I'll use the top rightmost version since it has more color variations. Since I'll be blocking out more levels, I decided to spend some time trying to make my blockout process faster. Taking what I learned from making the prop palette, I wanted a window that would let me drag different blockout prefabs. In preparation, I made more variants for the different diagonal pieces in larger blocks. My end goal was to have something similar to this. I started by making my own window, similar to the prop palette and only displaying the prefabs. In this clip, I made my own custom drawing method and just drew the asset preview before updating the visuals. I spent quite a bit of time trying to get a rotated texture and eventually found this post. Since that answer used linear algebra to transform pixel positions, I knew it was technically possible to rotate by any degree with some math. Instead of relearning that math, I asked ChatGPT for a very specific function and it gave me a solid solution. To validate, I swapped textures to rotate by 30 degrees regardless of their actual rotation. Then, I changed the rotation value on the assets that needed to be rotated. The next feature I worked on was adding drag and drop functionality. I spent a bit of time researching ways of doing it and found the Cerenics Editor Fields class, which is the same class that the Odin Preview Field attribute uses. This gave me the drag and drop behavior I wanted. After a bit of cleanup, the palette was working the way I wanted, except the rotations were inverted, which I simply just had to subtract the Euler angle's z-value from 360 to get the right rotation. I may add tabs and further categorize this in the future, but for now, it does what I need. That's it for this devlog. My focus for the next part will be add patrolling behavior to the pufferfish, update the player's horizontal movement, create the first level in the third world. If you want to support me, please visit the Don't Drown store page linked in the description and add the game to your wishlist. Until next time.